It is not safe to tie new troffers into existing 14.3 nm wires. 14.3 nm cable is not approved for use in commercial buildings and is not designed for the high temperatures associated with fluorescent lighting fixtures. It can overheat and pose a fire hazard. The required actions are: firstly, remove the existing 14.3 nm cable. Secondly, install new NM-B cable that is rated for the wattage and number of fixtures. Thirdly, ensure that the new wiring is properly sized according to the National Electrical Code. Fourthly, install the new troffers in accordance with the manufacturer's instructions. Additional recommendations include: firstly, have the electrical work performed by a qualified electrician. Secondly, check with your local building code to ensure compliance with any additional requirements. Thirdly, consider installing energy-efficient LED troffers to save energy and reduce maintenance costs. When dealing with electrical installations, especially in commercial settings, adherence to safety standards and electrical codes is paramount. The existing 14.3 nm cable presents a safety risk because it's not designed for the environment it's being used in. Firstly, let's discuss why 14.3 nm cable is unsuitable for commercial buildings, especially with fluorescent lighting fixtures. The NM designation stands for non-metallic sheath cable, commonly used in residential wiring. It has limitations regarding temperature ratings and permissible uses. Commercial buildings often have more stringent requirements due to higher occupancy, greater potential for electrical load, and different construction types. Secondly, the old 14.3 nm cable, as opposed to NM-B, indicates it's an older type of wiring which may not meet current safety standards. The NM-B cable has improved heat resistance, typically rated for 90 degrees Celsius, while older NM cable may have a lower rating, making it prone to overheating in demanding applications. Thirdly, fluorescent lighting fixtures, particularly those with ballasts, can generate significant heat. Ballasts, which regulate the current to the fluorescent lamps, are known to produce heat as a byproduct of their operation. When enclosed within a troffer fixture, this heat can build up, potentially exceeding the temperature rating of the surrounding wiring. Fourthly, the 14.3 designation indicates the wire gauge and the number of conductors within the cable. The number 14 refers to the American wire gauge, or AUG, of the conductors, which determines the current carrying capacity of the wire. The number 3 indicates that there are 3 conductors within the cable, typically a hot wire, a neutral wire, and a ground wire. Now let's discuss the dangers of using undersized or improperly rated wire. Overheating is a primary concern. When wiring is subjected to temperatures beyond its rating, the insulation can break down, leading to short circuits, ground faults, and ultimately, fire hazards. In commercial buildings, where there's often a higher concentration of electrical equipment and occupants, the risk of fire can have catastrophic consequences. The NEC provides guidelines for selecting the appropriate wire size and type based on the application, load requirements, and environmental conditions. It's essential to consult the NEC and local building codes to ensure compliance. The proper procedure for replacing the wiring and installing new troffers involves several key steps. Firstly, and most importantly, always to energize the circuit before working on any electrical components. Turn off the power at the circuit breaker to ensure that the wires are not live. Use a voltage tester to verify that the circuit is indeed energized before proceeding. Secondly, remove the existing 14.3 nm cable. Carefully disconnect the old wiring from the circuit breaker on the lighting fixtures. Remove the cable from the electrical boxes and any other supports it may be attached to. Dispose of the old cable properly in accordance with local regulations. Thirdly, install new NM-B cable that is rated for the wattage and number of fixtures being installed. When selecting the new NM-B cable, ensure that it's appropriately sized for the load requirements of the troffers. Consult the NEC tables to determine the correct wire gauge based on the amperage of the circuit and the length of the wire run. Also, ensure that the cable is rated for the environmental conditions of the installation, including temperature and moisture. Fourthly, properly secure the new NM-B cable to the electrical boxes and supports using appropriate connectors and fasteners. Ensure that the cable is installed in accordance with the NEC guidelines, including proper spacing and protection from physical damage. Fifthly, connect the new NB cable to the circuit breaker and the troffer fixtures. Make sure that all connections are tight and secure, using appropriate wire connectors. Observe the correct polarity when connecting the wires, ensuring that the hot, neutral, and ground wires are properly aligned. Sixthly, install the new troffers in accordance with the manufacturer's instructions. Follow the manufacturer's guidelines for mounting the fixtures, connecting the wiring, and installing the lamps or LED modules. Ensure that the fixtures are properly grounded to provide additional safety. Now let's address the additional recommendations. Engaging a qualified electrician is always advisable, especially for complex or critical electrical work. A licensed electrician has the knowledge, skills, and experience to perform the installation safely and in accordance with the applicable codes. They can also identify potential hazards and recommend solutions to ensure the safety and reliability of the electrical system. Checking with local building codes is also essential. Building codes vary from one jurisdiction to another, and they may have specific requirements for electrical installations, including wiring methods, materials, and safety devices. Consult the local building department to ensure compliance with all applicable codes and regulations. Considering energy-efficient LED troffers is a smart move for both energy savings and reduced maintenance costs. LED troffers consume significantly less energy than traditional fluorescent fixtures, resulting in lower electricity bills. They also have a longer lifespan, reducing the need for frequent replacements. LED troffers are available in various color temperatures and light output levels, allowing you to customize the lighting to suit your specific needs. Now, let's look at the specific issue of the existing wiring configuration. The mention of 14.3 nm cable being daisy-chained and connected to two ballasts, with a red and black conductor twisted together, indicates a potentially hazardous and non-compliant wiring practice. Firstly, daisy chaining refers to connecting multiple devices or fixtures in a series, with the power running from one device to the next. While daisy chaining is sometimes used in electrical wiring, it can lead to problems if not done correctly. Overloading the circuit is a common concern, as the total current draw of all the devices connected in the chain may exceed the capacity of the wiring or the circuit breaker. Secondly, the fact that the old lights have two ballasts, with one hooked to the red and one hooked to the black, suggests that the electrician attempted to split the load between two conductors. While this may seem like a way to increase the capacity of the circuit, it's generally not a safe or compliant practice. The NEC requires that conductors be properly sized for the load they are intended to carry, and splitting the load between multiple conductors without proper engineering calculations can lead to overloading and overheating. Thirdly, the mention of someone twisting the red and black conductors together and backfeeding some of the lights indicates a serious wiring error. Backfeeding occurs when electricity flows in the opposite direction than intended, potentially energizing circuits or devices that are supposed to be de-energized. This can create a significant safety hazard, increasing the risk of electric shock or fire. A properly designed and installed electrical system should never allow for backfeeding to occur. The fact that this wiring error rendered one of the switches useless is another indication of a problem. Switches are designed to control the flow of electricity to specific devices or circuits. When the wiring is improperly configured, the switch may not function as intended, leading to confusion and potentially dangerous situations. The action of twisting the red and black conductors together is a clear violation of electrical safety principles. Electrical codes require that conductors be properly insulated and separated to prevent short circuits and ground faults. Twisting the conductors together can damage the insulation, creating a pathway for electricity to leak and increasing the risk of electrical hazards. Given the unsafe wiring conditions described, it's imperative to take immediate action to correct the situation. The best course of action is to remove all of the existing wiring and replace it with new, properly sized and installed wiring that meets the requirements of the NEC and local building codes. A qualified electrician should perform the work to ensure that it's done safely and correctly. It's also important to address the underlying cause of the wiring errors. Investigate the history of the electrical installation to determine why the wiring was done incorrectly in the first place. This may involve reviewing the original plans, inspecting the existing wiring, and interviewing the people who performed the work. Understanding the root cause of the problem can help prevent similar errors from occurring in the future. In addition to correcting the wiring errors, it's also advisable to conduct a thorough inspection of the entire electrical system. Look for any other signs of damage, wear, or non-compliance. Address any issues that are identified promptly to ensure the safety and reliability of the electrical system. Furthermore, consider implementing a preventative maintenance program to help keep the electrical system in good working order. This may involve periodic inspections, testing, and cleaning of electrical components. A well-maintained electrical system is less likely to experience problems and is more likely to operate safely and efficiently. In summary, replacing troffers safely requires careful attention to detail, adherence to electrical codes, and the use of appropriate materials and techniques. It is essential to avoid shortcuts or compromises that could jeopardize the safety of the installation. If you're not comfortable performing the work yourself, it's always best to hire a qualified electrician to ensure that the job is done correctly. Replacing troffers in a commercial setting requires a systematic approach to ensure safety and compliance with electrical codes. Firstly, planning and preparation is important. Before starting the replacement process, develop a detailed plan that outlines the scope of work, materials needed, and safety procedures to be followed. Obtain all necessary permits and approvals from the local building department. Gather the necessary tools and equipment, including screwdrivers, wire strippers, voltage testers, and safety gear. Secondly, disconnecting the existing troffers will be needed. Turn off the power to the circuit at the circuit breaker. Verify that the circuit is energized using a voltage tester. Carefully disconnect the wiring from the existing troffers, taking note of the wire connections. Remove the old troffers from the ceiling, taking care not to damage the ceiling tiles or grid. Thirdly, inspect the existing wiring. Examine the existing wiring for any signs of damage, such as frayed insulation, corrosion, or loose connections. If any problems are found, repair or replace the wiring as needed. Verify that the wiring is properly sized for the load requirements of the new troffers. Fourthly, install the new troffers. Mount the new troffers in the ceiling following the manufacturer's instructions. Connect the wiring to the new troffers, ensuring that all connections are tight and secure. Observe the correct polarity when connecting the wires, ensuring that the hot, neutral, and ground wires are properly aligned. Fifthly, testing and verification is required. Turn on the power to the circuit breaker. Test the new troffers to ensure that they are working properly. Verify that all connections are secure and that there are no signs of overheating. Use a voltage tester to confirm that the wiring is properly grounded. Sixthly, documentation is useful. Keep a record of the work performed, including the date, materials used, and any problems encountered. Take photos of the installation before and after to document the changes made. Provide the building owner or manager with a copy of the documentation for their records. Throughout the troffer replacement process, safety should be the top priority. Always wear appropriate safety gear such as gloves and eye protection. Work in a well-ventilated area to avoid exposure to dust or fumes. Use caution when working at heights, and use a ladder or scaffolding that is in good condition. Follow all electrical safety codes and regulations. By following these steps, you can safely and effectively replace troffers in a commercial setting. Remember to consult with a qualified electrician if you have any questions or concerns.